Hello there. We're going to work on our Bridges workbook pages 55 through 57. The first thing I want you to do is turn to page 55 in your workbook, and that page looks like this. Okay, and we're talking about groceries. So Gregory bought some apricots for his sisters. Each apricot cost 15 cents, and he bought 3 apricots for each sister. How much did Gregory spend altogether? Show your work right here. Then decide which one of these equations represents the problem the best. For problem number 2, it says Lucia bought 3 pounds of carrots for 75 cents a pound. She also bought a box of crackers. In all, Lucia spent $4.54. How much did the box of crackers cost? You need to show your work. And then which one of these shows the best equation? What I want you to do now, and we won't have time to work on the challenge, but if you wish to work on that, you can, and some of you can compare your answers. So thinking about this, I want you to work real hard, have a class discussion, and then I will talk you through as best as I can. Okay, so you've had some time to think about this problem that we were working on. So the first thing that we're thinking about is that what Gregory did, he wanted to buy some apricots. So each apricot costs 15 cents. And so he bought 3 apricots for each sister. So if we think about that in the form of a ratio table, for one of his sisters, how much money did he spend? So 15 plus 15 plus 15, 3 times 15 is 45. So for one sister, he spent 45 cents. However, he didn't have just one sister, he had 3 sisters. So if we don't know how to multiply 3 times 45, we can work it out on a ratio table. So think about it. When we double that, 45 doubled is 90. Now remember, we want to get to 3, so 1 plus 2 equals 3. So we simply add 45 plus 90 to get our 135. So when we figure out which equation best represents that, which one did you pick? I hope that you've discussed it and you figured out which one works the best. So I hope you picked out number 1, because we have 3 sisters times 3 apricots times 15 cents. 3 times 15 is 45. See, right here, times 3 again. So that's how this is represented. If we look at this, it's like we have 3 sisters plus 15 cents plus 3 apricots. Doesn't make any sense. Thinking about this one, okay, so say that we have 3 apricots times 15 cents is 45 cents minus 3 sisters. That doesn't make any sense either. So that's how come that one doesn't work. Moving on to this bottom one. This one's a little more complicated because we haven't talked about subtracting with regrouping yet in school. We've done it informally. Your parents probably showed you over the early or that or over spring break last year. That's the spring break that went on forever until September. So we are going to talk about this, but we're going to talk about how to figure this out using something that you already know. Okay, so what I did to help explain how to find the answer for this and if this is different from what some of you figured out in class, that's fine. But I was thinking that a strategy we've already used this year is a number line. So we need to have a starting point for our number line. Our starting point is this. Lucia bought 3 pounds of carrots for 75 cents a pound. So we can think of it this way. We could set up a ratio table if we wished, where we would have 1 pound is 75 cents, 2 pounds is $1.50, 3 pounds is $2.25. So we've already figured that out. But then we have to figure out how much she spent on the crackers because we know her final number is $4.54. I chose to do a number line to solve this one instead, and this is the reason why. Because now if we think about where we started, we have $2.25, and we have to get to $4.54. So thinking about this, we know that we have to make a jump of this. This is how much she spent on carrots. This is how much she spent on the crackers, and this is her total. So to figure that out, we can divide up however we want to for little jumps. So I chose to do my first jump to $3. So we did a little jump from, let's do a different color, from here to here, which is 75 cents. So $2, 2.25 plus 75 cents gives us $3. So now that we're already at the $3 mark, can we figure out in our heads, if we're at $3, how much more do we need to jump to get to $4.54? Think about it. From $3 to $4 is $1. From $4 to $4.50 is 54. So I combined those two. Oh, let's clear this out. I combined those two and thought about my jump being, let's get rid of this, $1.54. So now we have our jump, our second jump from here, from here to here, which means now we need to add $1. Ooh, I'm not so good at writing this stuff yet. I'll get better. Plus 75. Okay, so 4 pennies plus 5 pennies, 9 pennies. 5 dimes plus 7 dimes gives us 12 dimes. Well, I can only put my 2 dimes in that column. Carry the rest of those, which make a complete dollar, over into my dollars column. $2.29. I know some of you maybe did $4.54 minus $2.25 to get that same answer. But as I said, we haven't formally learned about how to regroup in subtraction yet. So using a number line and counting up at this point might be the easiest option for many of you. Okay, now looking at the equation that we're supposed to use. Let's look at each of these to see which one works and which one doesn't. So if we have our total of $4.54, we minus the cost of the crackers, it's going to give us 75 cents. No, that doesn't make sense because right here, look, 3 pounds of carrots for 75 cents a pound. So it can't be that one. Next is 3 times 75 cents. Okay, that makes sense. 3 groups of 75 gives us 225. See, that's what we started with here. And then from here to here is the cost of the crackers. So 225 plus the cost of the crackers equals $4.54. Makes a lot of sense. Haha, makes a lot of sense. Haha. Okay, and the very bottom one, we're looking at 3 pounds of carrots plus 75 cents. Okay, first of all, 3 pounds of carrots plus 75 cents isn't going to work real well. And now we're timesing it times our crackers. So that one doesn't work at all. So it would be this one. Okay, and like I said, we're not going to take time to do the last one. Hope that this one worked well for you. Now we're going to move on to another couple of pages. The next pages are not interactive, so I need to go back and forth between our number pieces board and our workbook page. So the workbook pages look like this. So this is what page 56 looks like. This is what page 57 looks like. And so let's look at our example. Oops, went too far. Here's our example. Okay, it says for each frame below, label the dimensions with a regular pencil and then imagine the area of the rectangle once you have filled it in. So in other words, when they're saying imagine the area of the rectangle, think about if that was filled in with the base 10 pieces. Then you can check your thinking by making a quick sketch, which is what they mean by this thing right here. And then you're going to write the area. Let's see, write the area of each rectangle. See, area. And then you're going to write an equation. You see the equation down here. So if we look this one over, this one starts out with 5 little pieces going down the side. We have a base 10 across the top plus 2 more. Since this is a 10, we sectioned this into a 5 times 10. Do you see that right here? 5 times 10 equals 50. So they put 50 in that box. So if we were doing that with base 10 pieces, we know that there would be 5 groups of 10, those long pieces. Then we have this other small spot where we would have our dimensions of 5. Remember, oh, right, this is 5. If this side is 5, this side is 5. And then we have a 2 across the top, so we have to do the side times the top. 5 times 2 equals 10. We add 50 plus 10 equals 60. The multiplication equation we did is 5, that's this number, times 12. Where did the 12 come from? Stop a moment and think. Where did that 12 come from? Okay, I hope you noticed. 10 plus 2 equals 12. 12 is distributed across the top of our rectangle. So this is the first one you're going to work on. I want you to try doing this on your own, and then I'm going to talk you through that. So I'll pause the video. Okay, so I've drawn this using my base 10 pieces. Obviously, I can't draw on the board that you had. But if we look at what our workbook page versus this, you can see it's the same thing. Since I see this line, I know that the line means that it is 10. So I'm going to put my 10 over here. And I know that this is also a 10. So I'm going to put my 10 above it. And I have 1, 2, 3, 4, 5. So I'm going to write my 5 above that. Okay, double checking, make certain that this is the same as what is being shown in my workbook. 1, 2, 3, 4, 5, 6, 7. Uh-oh, I wrote it wrong. I've got to fix that. Good thing I checked. So that is a 7. And I need to make some more pieces. Let's see, so there's 1 and there's 1. Okay, so 1, 2, 3, 4, 5, 6, 7. Double check to make certain my worksheet's the same as yours. 1, 2, 3, 4, 5, 6, 7. By now, I bet many of you have this finished. So it told us that we're supposed to draw the array on the inside. I'm going to use a different color to do that. Let's see, how about orange? Okay, so I have this part of my array. Times this part of my array. And now remember, our workbook tells us that we are supposed to come up with our the equations or the area for each of our boxes. So the first box is 10 times 10. Shout out, what is the answer? Good, because I shouldn't have to tell you that anymore. We've been talking about that a lot. Let's see if I got more room. There we go. Okay, so we have a 10 times 10 equals 100. So I'm going to put 100 inside this box. Okay, and now we have the dimensions of this one. Remember, however long it is this way, it's going to be the same as it is over here. 10 times 7 equals, what is 10 times 7? Shout it out. Okay, good. So now I need to write the answer inside of that box. I know my boxes aren't the same, but I'm certain that others are not quite the same as well. Okay, so my question, are we finished now? What were your directions on this page? What did it tell you to do? Did you do all of this? Notice here's 10, 5 times 10, 5 times 2. Look at this. Here we have one of the products, which is 50. Here's the other product, which is 10. 50 plus 10 equals 60. So that's what I need to do next. Did you do that as well? So I need to write 100 plus 70 equals, and what does 100 plus 70 equal? Yep. So there we have it. And are we finished? Let's double check. We are not. It tells us we have to have an equation. A lot of students miss this. They don't understand where all the pieces come from. When they ask you to write the multiplication equation, they're asking you to use the dimensions. What are the dimensions on this drawing? Okay. Most times, this is what I'm from experience, we have our 10, which is this one, times. Now I'm going to use parentheses to help you understand where our other number comes from. So I'm going to pull this down. Maybe I'll pull it up. If I can grab it, there we go. Let's pull it up. Look at this. I'm going to line it up. Here's one of our 10s. And then here is our 10 plus 7. We have to add these two numbers together. We have to add these two dimensions together because they're all on the same side. Look at this. They're all together there. I've told some students so that they can remember that they're supposed to add these together to circle. Oops, I don't have it. There we go. Here is one of our dimensions. Here is the other dimension. So 10 times 10 plus 7, which is 17. So this would be 17. 10 times 17. Okay, I'm going to pause to get the next one ready for you. Okay, so this is what your next page looks like. I have drawn that on my number pieces grid, and it does not look quite as nice as this, but I want to talk about what to do because did you notice we have this 10, we have this 10, then we have some pieces, and we have some pieces. So we have to think about what are we going to do? So going to this, here are the pieces that I was talking about, and the book tells us that we should draw the arrays. So I'm going to pause this while I get a few of the arrays going for you. Okay, notice that I drew in the array. Right now I have the boxes kind of separated. The next time that we make one of these, I'm not going to separate the boxes like I have on this one, but I want you to see where our equations are coming from. So notice now that we have black numbers across the top and green numbers on the sides, and I made them separate colors to try to prove a point. Some people at this point don't understand where these numbers come from when we're multiplying. I'm going to pause and put some equations inside of each of these boxes so you can better understand where these equations are coming from. Okay, so if you notice now that I've got a bunch of colors all over and this may look a little confusing, but I want you to understand where each of these factors, where each of these dimensions are coming from. So notice we have a black 10. Our black 10 is up here. And we have a green 10. Our green is on the side. And notice that we are multiplying a number from the top and a number from the side. 10 times 10 is 100. Yes, everybody knows that. Looking at this one next to it, again, we have a green number and a black number. The green number from the side, 10. The black number from the top. We have to do a side times the top. We already did this one. We're done with this box. So now we need to move on to this box. 5 times 10 is 10 times 5 is 50. Moving on to these boxes below, again, a black number and a green number. Here's our green number, our side number, and our top number, just like a multiplication chart. These things work in columns and rows. See, our column, our row. Here again, our green number from the side, our black number from the top, a column and a row. 5 times 2 is 10. So as if we would be doing this the way that our workbook is asking us to do that, we will have a big bunch of equations right here. So give me a moment, I'm going to do that. Okay, to save you some time, I wrote all 4 equations. So we have 10 times 10 equals 100, 10 times 5 equals 50, 10 times 2 equals 20, 2 times 5 equals 10. It doesn't matter which order you put these in. It doesn't matter if you have 2 times 10 instead of 10 times 2. It doesn't matter if you have 5 times 10 instead of 10 times 5. It doesn't matter if you have 5 times 2 instead of 2 times 5. Either way, you know that the commutative property of multiplication means that you can switch the factors around and still have the same product. So remember, our workbook is asking us to write down all 4 equations, each of the partial products from this total array. So we have those 4 products. When we add those 4 products together, 100 plus 50 plus 20 plus 10, that equals 180. But now we need to write what our equation is. It asks us for our multiplication equation. And remember, we've talked about our equation being the dimensions on our 2 sides. So here, try this again. Here is one set of dimensions, and here's our other set of dimensions. Sometimes students will do this so they remember that they have to add their dimensions together. So now that we've done that, I'm going to write our equation for our dimensions. And that would be 15, because 10 plus 5 is 15, times 10 plus 2 is 12, equals 180. And so this is our final multiplication equation. All of this work came right out to this. Okay, and so now we have one more that we're going to do, and this next time I'm not going to make these boxes all look individual. I want you to see what you will be doing in the future to make things work faster. Remember in yesterday's lesson, as we were talking about this, we're looking for ways to become faster and faster, but first we have to understand what we're multiplying to begin with. So I'm going to pause for a moment while you work on number 3 and I work on number 3. Okay, so this is what number 3 looks like in your book. And like I said, I can't write on this thing, so I'm going back to my number pieces board and I drew it out for you. Remember, I said that this time I'm going to just draw lines to save time. So I want you to think about this. Hopefully you did the same thing. So let's get our drawing. Let's change our color. And we would have something drawn down here. We would draw this all the way over to there. Boy, isn't that faster? Okay, we'll draw this down to about there, it looks like. And we'll connect these. But now we also have to remember that we have it cut right here. And we have it cut right there. Okay, it wants us also to write our dimensions, so we need to do that. So let's get our number pieces out, our number equations. So we have a 10. So put that 10 here. And we have another one. Okay, and then we have a 4. And 1, 2, 3, 4, 5, 6, 7, 8, and we have 8 over here. Okay, so we have the dimensions already written. When we look at this, we have to think about a side multiplied by a top, or a top times a side. So 8 times 10 is 8 times 10 is 8 times 4 is. Remember, we have to go just like a multiplication table. So I'm going to quickly type those all in. I'll be right back. Ta-da! Just like that, I have everything up there for you. So remember, we did 8 times 10 is 80, 8 times 10 is 80, 8 times 4 is 32. Remember, you have to do a side times a top, a side times a top, a side times a top. So now that we have this, we need to magically make our 3 products add together for a sum. Ta-da! Now we suddenly have our three products added together because this is part of our product, this is part of our product, and this is part of our product. The last portion of this page tells us we need to come up with our equation. This is all about finding our multiplication equation. Remember, I've told you that you need to have a dimension on the side and a dimension on the top. Right now we have 3 dimensions on the top. Actually, what we did with them is we have distributed them into smaller pieces. So now let's reassemble them. I've told you in the past that what some of my students in the past have done is put a plus sign right here and a plus sign right there so that we know we have to add 10 plus 4. So if we add this part, that gives us 24, 10 plus 4, times 8 equals 192. So the multiplication equation is 24 times 8. 10 plus 4 equals 24 times 8. Okay, again, what we did is we have split our factors into easier to use numbers for multiplying. Okay, this may have confused you, or this is maybe making sense to some of you. The more that we practice this, the easier that it will get. Okay, next is learning a game.